Welcome back to All This Math. Today's lesson is on factoring. Now, I want you to pay special attention and careful attention to today's lesson because factoring is such a fundamental aspect of algebra, and then which you'll also need in Algebra 2, which you'll need in pre-calculus, which you'll need in trigonometry, which you'll even need in geometry, because geometry, for real, is just algebra with shapes. That's all that is, So, and this is like the first type of factoring, because depending on what the expression looks like, there's about 5 to 7 different types of factoring that couldn't be done, So, but factoring by doing what we call as taking out a GCF, or a greatest common factor, that's the fundamental. That's the fundamental type of factoring. That's the first type of factoring that you should encounter. All right, because it kind of sets you up and feeds into all the other different methods of factoring. All right. Now, also, since it is August, it's August 2022 as I sit here and record this video up in my office at Cheney University, right? I got on my NatTurner Day t-shirt that I got many years back, maybe about 7 or 8, 9 years ago, something like that, maybe 10, I'm not even sure, right? It's only right because it is Black August, and one of the events that's commemorated during the month of Black August is NatTurner's Slave Rebellion. NatTurner's Slave Rebellion, which took place near Southampton, Virginia, back in 1831. So if you're not too familiar with that, go do some research. Do your research on that. All right. I wouldn't necessarily read the book by William Styron. I'm not really a fan of that. There's a lot of other research on that, on NatTurner's Rebellion, that you can check out and you can look into. But definitely make yourself well aware of NatTurner's Slave Rebellion, which took place near Southampton, Virginia, back in 1831. All right. So we want to factor, right? But first off, what does that even mean? When you factor something, one way to think about it is you take something like an object or an entity and you break it down into smaller parts or different parts that could then be recombined back into the original object, right? So, think about it like a salad, right? You make a salad, you put some different ingredients in it, but what if you separated each of those individual ingredients into their separate parts after the salad was made? That would be like factoring, right? You take your different, like your lettuce, you take if you put some seafood in it, the salad dressing, maybe some Parmesan cheese or something, whatever you put into the salad, you break it down into its individual parts that go together to compose the salad. That would be factoring if you separate all those individual parts. So that's kind of what we're about to do right here with this expression. So this expression is one expression. The 8x minus 24, even though it's like two terms, 8x and a negative 24 put together, they're put together as one expression. That's one expression. But what we're going to do when we factor it is we're going to break it down into separate terms or separate parts, all right, or separate factors. And this is how we do that. So you look at these two terms, right? Or however many terms you have. In this case, I got two terms. And you say, okay, well, what is the greatest common factor of those terms, right? So I look at 8, and then I look at 24, and then I say to myself, because I know my multiplication facts, I know what the greatest common factor of 8 and 24 is. I know that it's 8 because I know that 8 times 8 is 1. I'm sorry, I'm tripping. 8 times 1. What I meant to say was 8 times 8 is not 1. 8 times 8 is 64. But I meant to say that I know that 8 times 1 is 8. And I also know that 8 times 3 is 24. So therefore, my GCF, or my greatest common factor that I was just using, is 8. So that's a very important thing, right? So what you want to do is somewhere, you might want to just on your paper, if you're new to this, just label what the GCF is. Just say GCF is 8. And GCF stands for greatest common factor. Greatest common factor. The greatest common factor. That's what GCF stands for, right? Now, greatest because it's the biggest number, right, out of a group of numbers that they might have in common, meaning that they share, or meaning that can be multiplied into both of these numbers evenly, right? The greatest one, because 4 is also a common factor. 4 can be multiplied into 8. 4 can be multiplied into 24. But 8 is bigger than 4. 2 can be multiplied into 8. 2 can be multiplied into 24. But again, 8 is bigger than 2. That's where the G comes in. G stands for greatest. You want the greatest. You want the biggest number. The biggest number out of all the numbers that these numbers have in common that can be multiplied into that, you want the biggest one. And then the factor is just that, the number that can be multiplied into each of these numbers. Now, sometimes variables will have common factors, but not in this case because these two terms do not have x in common. Only the 8x has an x. The 24 doesn't have an x. So x is not common. But 8 and 24 share the 8 in common. That's what they have in common. So that's the greatest common factor. The greatest common factor of 8 and 24 is 8. All right? It's not 4, even though 4 is a common factor for both of them. It's not 2, even though 2 is a common factor for both of them. It's not 1, even though 1 is a common factor for both of them. All right? So I'm talking a lot about this because I want to drive home this fundamental concept of what a common factor is and what the greatest common factor is and just what a factor is and how you find it. But it all goes back to knowing your multiplication facts. So if you have not memorized your multiplication tables and your multiplication facts from at least from 1 times 1 up to 12 times 12, you got to do that. Do yourself a favor. You got to go familiarize yourself, become well versed with the multiplication facts because that's what's going to hold you back. If you don't know your multiplication facts, math is going to be hard. I'm going to just tell you straight up. It's going to be hard. And for a lot of people, they don't understand, like, that's the fundamental element that's been holding them back. That's why math gets hard, because you be having to do too much. If you just knew what, like in this problem, right? If you know that 8 times 1 is 8, and if you know off the top of your head that 8 times 3 is 24, so whenever you see a 24, you automatically thinking like, oh, 8 times 3, 12 times 2, 6 times 4, 2 times 12. If that's how your brain operates because you're just so familiar with your multiplication facts, the math becomes a lot easier. But if you're not that person and you don't know your multiplication facts yet, that's when it gets hard because you got to sit there and think, oh, well, what number multiplies by this to get that? And, and that's when you get frustrated. And that's when you want to quit. And that's when you start saying, oh, I hate math. And that's when you start saying, oh, when am I going to use this stuff? It don't matter anyway. And then you start to rationalize not, learning something when all in all, the reality is just the solution to the problem is just learning your multiplication facts. So just do yourself a favor, learn the multiplication facts. The math, it will get challenging sometimes, but at least it'll be challenging for other reasons, not fundamental basic reasons. All right. So our GCF is 8. So now how do we set this problem up? We first write our GCF next to the equal sign. Write the 8, and then we write a set of parentheses. Just like that. So you got your GCF, and then you got a quantity. GCF and a quantity. Your GCF and a quantity. Not a question you should be asking yourself is, well, what goes inside the parentheses? That's the next question. What goes inside the parentheses? Because you got to put something in there. It's not just going to be some empty parentheses. Like, why would I just write empty parentheses, right? Now, this is how you figure out what goes inside the parentheses. You got to do division. So you take each of these original terms and you will divide them by the GCF. That looks like this. You're going to take 8x and divide it by 8. 8x divided by 8 is just x because 8 divided by 8 is just 1. So you have 1x. 1x is just x, right? And then you're going to divide the negative 24 by 8. So then you do negative 24 divided by 8. Negative 24 divided by 8. Now again, I just talked about knowing your multiplication facts. Another benefit of knowing your multiplication facts is that if you know your multiplication facts, you will very likely know your division facts. Because if I know that 8 times 3 is 24 already off the top of my head, I also probably know that 24 divided by 8 is 3. And that's what it is. So negative 24 divided by 8, of course, when you're dividing a negative by a positive, you get a negative quotient. So that's minus 3, not plus 3, minus 3. Be very careful. Pay attention to those details. A negative divided by a positive is equal to a negative. Again, a negative divided by a positive is equal to a negative. So this is x minus 3. This is the quantity x minus 3. So this is your answer. This is the factored form of 8x minus 24. So if I take 8x minus 24, remember that salad, right? You got that salad, and let's say you could separate all the individual ingredients out back into their individual spaces, right? Back into their as individual entities, right? I don't know how you could do that, but let's say you could, right? It would look like this. 8 is a factor and x minus 3 is a factor. So you got two factors. You got two factors. You got an 8 and you got an x minus 3. So you had one entity, one expression, 8x minus 24. We took the one expression, we broke it down into two separate entities or two separate expressions. This 8 is one expression, and this x minus 3 is another expression. So now we just factored. Now let's say this. What if I wanted to check my work? If I wanted to check my work, I would do this. I would multiply using the distributive property, because multiplication is the opposite of factoring, right? Or I should say this. I should say distributing is the opposite of factoring, because in reality, multiplication is the opposite of division, right? So if I multiply this out, my product should be equal to the original expression. And if it is, that's how I know that my answer is right? As long as I got the GCF, the proper GCF, because I could have a common factor that's not the greatest common factor and it would still equal out back to the original, but you'll see that in other situations. But for now, because we know we have the GCF, we don't got to worry about what I just said. We know the GCF is 8 because it's got to be, because 4 is not it, 2 is not it, and 1 is not it. It's 8. So you do 8 times x, and that's going to be 8x. And then you do 8 times negative 3, and that's going to be negative 24. And notice that we started out with 8x minus 24. So that's proof that this is correct. So this is how you check your work. So once you factor, you should either multiply this out, multiply your answer out in order to check it, to make sure that your product is equal to what you started with. You either write it out or do it mentally. One way or the other, you should always check your work. That's something you should get into the habit of. If you're not already in the habit of always checking your work, whenever possible, if you know how to, always check your work. You know what I'm saying? So just check your work. So this is factoring by taking out a greatest common factor. And this is very important. This is very fundamental, very important. This is the type of thing that you will see over and over again throughout algebra. And again, you'll see it in geometry, because like I said, geometry is just algebra with shapes. You'll see it in algebra 2. You'll see it in pre-calculus. You'll see it in calculus. Trigonometry. You will always have to know how to factor as a problem-solving tool, right? Factoring is a problem-solving tool. And understand what we're doing when we're factoring. We're just taking a common factor, something that both terms or all the terms have in common. In this case, it was 8. And we're using it in order to basically break this up. 8x minus 24 is one expression. We want to break it up into separate expressions. So we broke it up into an 8 and an x minus 3. All right? So that's what we got. 8 times the quantity x minus 3 is the answer. 8 times the quantity x minus 3. All right? Now, I just showed you how to do this, and you might be looking at this and saying, oh, that makes sense. I know how to do it now. Okay, cool. Now, but I'm going to tell you this. You will not really learn it until you go practice on your own. Go practice. Go forth and practice. That's what I say in a lot of my videos. Now go practice. All right? So until the next video, go practice. Peace.